A little bit about me. My name is Kent Mitchell. I work for a company called Zend. Zend is the PHP company. We're sort of the commercial arm of PHP. So if you think about Red Hat and Linux, basically Zend is to PHP. We basically do a lot of open source work on PHP itself. We basically support an open source framework called Zend Framework. We stuck our name in there so you wouldn't forget. Basically, we provide a lot of open source work in PHP, and then we take that open source PHP stack and we add a lot of value on top of it. We've been around for over 10 years. We have quite a few customers, and these are some of our customers and our partners out there. Work with RightScale, Rackspace, Amazon, a number of different companies to provide services in PHP in their environment. So you've got some typical configurations that people set up with PHP. You've probably seen some of these before, but a lot of people set up an Apache web server. They have PHP. They use a MySQL database. If they're using PHP sessions, they use a standard PHP session handler. It writes the files on the file system. This works great when you have your own server. You build up your server, and everything's all in one place. It's easy to maintain. Not particularly fault tolerant should that server die. And you can approach the limitations of how much stuff you can actually cram onto one server at one time. You can keep buying bigger and bigger servers, but eventually you reach sort of a practical limit. Unless you're like our folks at IBM who think you can build a server that just keeps getting bigger and bigger and bigger, and they're right, but eventually you run into problems. Sometimes the first things people do is they say, well, I'm going to separate out the database server. So they move the database server to another server, and that's great because MySQL, pretty much that's transparent. Whether you're running with the MySQL on the same server or you're running with it somewhere else, this will basically, give you sort of some typical configurations. There are also some other configurations that people will set up on premise. They'll set up a load balancer, they'll set up a couple of servers, and then they'll set up a MySQL server. And this works pretty good until you really start to grow. And then you have to add more servers, and eventually you're going to run out of the capacity on your database server. There are a lot of things here that work pretty good. But when you move to the cloud, there are a number of challenges here. So what are some of the main issues you're going to run into? Well, one of the biggest ones is sessions. By default, PHP stores sessions in the file system. So if you're going to scale up, that's not actually too much of a problem in a way. I can add a new server and new sessions get routed to that server. As long as I'm using a sticky load balancer, I'll get back to the same server that has the session as well. But if you don't use a sticky load balancer, you'll get back to some other server. It won't have the session and it won't work. And on premise, you could have solved that by maybe using an NFS mount point. I wouldn't recommend it. It's a stupid way to do it, but you could have solved it that way. And that would have worked. But you don't really have NFS mounts in the cloud. They just really don't exist. So you would have to come up with some other technique for this. And you might say, well, I'll store them in the database. I'll do this. I'll do that. These all have their various pros and cons. If you say I'm going to store them in the database, that means every time you want to use a session, the PHP server has to fetch it from the database, it has to operate on it, then it has to write it back to the database. So you've got 2 network hops to get your session every single time you hit the PHP server. Before, when they were in the file system, they were really fast, and if it was on Linux, Linux is probably already caching it for you. So you probably just slowed your system down tremendously just by doing that. So this is one of the challenges of just creating sessions that are going to work in the cloud across a bunch of servers. Scale up, as I said, is easy. Theoretically, you could scale up, and if you used a sticky load balancer, you'd be great. Scale down is hard. It sounds like it would be simpler, but it's actually harder. Why is that? Well, you've got these sessions. Let's say you are storing them in the file system. You are using a sticky load balancer. Now you want to get rid of this server, but it maybe has 500 sessions on it. How do you get rid of them? You can't just shut it down. You'd like to use RightScale, auto-scale it down, and you're done. Problem solved. They're gone. You just lost 500 sessions. And that's why people say, well, let's put it in the database. But you just lost those 500 sessions. Or you could say, well, I'm going to route old traffic to the server, and I'm going to not route any new traffic to it. You can have load balancer configuration. It's that way. It's pretty smart, but it's kind of complicated. And you could wait long enough after the last piece of traffic that ever went to that server for the sessions to time out, and then you could shut the server down. It's complicated, and there's really no good way to automate that. So a lot of times people move things into the cloud, they scale up, and then they're like, well, how the hell do I scale down? And they literally have problems doing this. So you've got this problem with sessions where it's just really hard when you move from something where you could do NFS mounts, you could control your own destiny, to the cloud where you've got a lot of advantages and that you can start a server, cheaply, run it for 2 hours, but getting rid of it's a lot harder than getting it. And it's one of those things. It's like, yeah, I could just scale up 5 more. Crap, now I got to wait like 3 days to get rid of them. We actually had the degenerate case of this. We had a customer whose sessions lasted a week. And the reason he wanted them to last a week, this was his requirement. I want people who come to my site, put things in the shopping cart. If they come back 3 weeks, a week later, I want it still to be in the shopping cart. I was like, okay. I didn't think it was the smartest thing to do, but that's what he wanted. So when he tried to scale down, he had a huge problem. He had to wait a week between scale downs of servers, basically. Yeah. He can do a lot of things. I mean, there are a lot of different ways of solving these problems. The question is, how much programming do you want to do to solve the problem versus how much would you like to have it taken care of for you? And so ideally, I'm just telling you things that will cause problems for you if you don't think about them. And you either have to program around them. Like I said, you could move the session handling to the database. It works. It's not terribly performant, and it worked, but it does work. The other thing that you have to think about is if you're planning on massive scaling, a lot of times people think, well, I've got to scale up my web servers. Well, at some point you're going to get enough web servers that your database server isn't going to scale anymore either. And so you've got problems like database scaling. Are you going to replicate? Are you going to mirror? How are you going to handle this across multiple regions? These are all things you go to the cloud for. Oh, I want to run it in multiple regions so that if one region goes down, I still have service. Great. How do you replicate your database across here? I'm not going to say that we solve this problem, but these are the kinds of things you face. Internally, you didn't face these problems because scaling up and scaling down didn't happen that often. If you wanted to scale up, you had to go buy a new server from Dell. 6 weeks later, it might arrive. Then you give it to your IT people. They might set it up. It might take them, 3 or 4 weeks. And finally, you put your software on it, and you add it to the load balancer, and now you've got a bigger system. And you basically would buy enough capacity to handle whatever your maximum load was because you didn't want to deal with this ever again. That's basically why you did those things. Other potential problems. What if a server crashes? So you can figure out how to scale down when you know it's going to happen, but what if a server crashes? Now, I don't think servers crash as often as they used to crash, and I don't think cloud servers crash off as often as physical hardware. It's just my observation so far. But they do die. Occasionally, servers just die or become non-responsive. So what you really want is a system where even when you don't know you're scaling down, you can still have high availability. So when that thing fails, the session is still there. Again, if you put it in a database, that's one option. It will work. Then I can hit any server and I can still get my session. Some other things, high availability database. So sometimes it's not just scaling it up and scaling it down for capacity. It's what do I do if one of my database servers fails? What if I'm using a master-slave MySQL system, what happens when the master dies? What do I do? Caching is another one that's interesting. People cache data, and a lot of people on-premise use memcached. Anybody here use memcached? Memcached is a really interesting technology, not necessarily the best technology in the cloud. Because again, it's one more moving part, and as you scale up, you can actually exceed the capacity of your memcache server. Now, memcache has ways of dealing with this. It has things where it can hash keys and route them to different memcache servers. I mean, you can have completely replicated memcache servers. But you start to do it in hops over the wire for caching. Your caching is sort of expanding, needs to expand. So what you've got is you've gone from a situation where you have a nice controlled environment that's of a certain size, and you know how to handle sort of the problems, to an environment that's much more fluid and changes much more rapidly, and you can run into these problems. So this is sort of the challenges that faced Mark at MediaSpike. MediaSpike is a great company that basically the job is to process leads for colleges, universities, that kind of stuff, and hand them off. These are the two sites they have. It's a pretty sophisticated matching algorithm to say, well, here's this lead, who should I route it to, and they run a lot of high volume campaigns. In general, and if I say anything wrong, Mark, correct me in real time. I have no pride of making mistakes here. One of the problems that MediaSpike had was they were running sort of, the big server thing. And Mark had the big server. I mean, it was really big. But he was basically at a point where he couldn't actually take on more business because he couldn't make this server any bigger. And, marketing would come and say, hey, we got this great new campaign. And it'd be like, well, we can run it in 3 weeks when this other campaign's done and we've got more server capacity. So needless to say, somebody who's smart said, we probably ought to figure out how we could actually take on more business when it actually comes in instead of walking away from it. Accurate-ish?
Pretty close.
Okay. So, here were sort of the problems he had. No room for traffic bursts, fragility. I can't really update this because if I update this other thing's running here. I mean, these are all problems you probably have experienced. If you haven't experienced them, count yourself very lucky, okay? Because these are not, really atypical problems. You got single point of failure. When do I shut this thing down? I got to do maintenance next week. When I do maintenance, my entire system's offline. So, in essence, instead of doing things, quote, right in all cases, sometimes you go out and you say, I'll just change this one file on the server because I know I can fix it right there and I won't have to deal with the whole problem of taking the server down. And then I don't know for sure this has ever happened, but I'm willing to bet at least once or twice, one of those hacked changes didn't make it back into the real code base, and later on the server was updated in the future, and something that was fixed suddenly became unfixed. I'm not going to put words in Mark's mouth, but I'm willing to bet that that's happened for at least somebody in the room.
At least twice.
So in essence, what you really need is you need something where you can create a PaaS-like environment. And you can have something where you have, this is the only part where I sell, and I'm not going to hard sell, I'm just going to talk about the thing in general. You have an environment where you can have a scalable set of servers. You have fault-tolerant load balancers. You can have database systems that scale up and scale down. And the idea is that if you can take something like this and put your application in it quickly and easily, and have it as much as possible be transparent, you can make this migration from on-site into a cloud, and we can take the value that Zend provides and the value that RightScale provides, and we can solve a lot of these problems. RightScale has out of the box mechanisms to scale up and scale down MySQL databases. They have solutions for other kinds of databases. They have solutions out of the box for fault-tolerant load balancers. They actually have several partners that do load balancing as well, so if you don't like that load balancer, the advantage of this RightScale solution is it's customizable. I'd love to use the term open PaaS, but I'm not allowed to use the term open PaaS as one term because somebody decided that they copyrighted that. So it's a customizable PaaS. You can go in and you can tweak it and tune it. And so what you've got out of the box in this solution is, from the Zend technology, automatic high availability sessions. So it will transparently take those sessions that we're going through the PHP session handler and writing to files, and it'll make them transparent across all these servers. It'll automatically make backups to everything with no other moving parts. So you're not writing them to the database. You're basically keeping them in memory. They're super fast, It works on Apache. It's basically a standard PHP stack running in standard Apache. We've just added some value-added things on top of it. Again, we work in PHP. We're the commercial arm of the open source. We take that open source and we add stuff on top of it. So essentially we've created an alternate session handler that knows about this clustering system, that knows how to make backups. It knows how to scale down too. If you want to shut a server down, it'll actually reestablish the HA on other servers and then it'll shut itself down. So it basically, without thinking about sessions at all, you've solved the session problem. You don't have to add a memcache server. You don't have to add a database server for the sessions. You don't have to add tables for them. It just takes care of it. Works with Postgres as well. So you've got basically that problem solved. RightScale will handle some of the other things like database replication. RightScale partners will give you things like full database sharding. So if you really need a completely, fault tolerant spread across the universe type system, go find a RightScale template for database sharding, take the one that's in the default implementation here, drag it out, drop in a new one. So what you've got here is a bunch of capabilities from Zend that can help you. A lot of them around sessions, caching, and so forth. So another thing is we talked about caching. A lot of people use Memcache. The great thing about Memcache is it's well known, it's popular, it works pretty good. But you've got to scale it up and down. Zend actually has a distributed cache. So it's an in-memory distributed cache, and it's basically cached on each server. So as you add a new server, it'll fill up its cache. When you write something to the cache, it invalidates it in the other caches, so it forces them to refetch it. The advantage is you never have to hop over the wire to the Memcache server to get something. It's going to serve it up out of memory. It has a buffer in the memory that if it overflows, it'll write to disk. So you do have, if you say I want 64 meg for my cache and you go over that, it'll push the older stuff to disk. So things you haven't accessed in a while. So it basically gives you that ability to handle these things. So Mark's original configuration was this big giant server, and this is where he ended up, I think. It may have tweaked since this was done, because I think he's constantly evolving it as he learns. But you got a couple of fault-tolerant load balancers. So if one of the load balancers dies, RightScale will just start another one. You've got the Zend server nodes, which are basically your scalable array. We actually have 2 that are there statically. So he never goes below 2 because 2 gives him fault tolerance. So one of the things you've got here in this solution is no more single point of disastrous failure. So we did point out that if the Memcache server goes down, it's a single point of failure. It'll start up again. It'll repopulate the cache. That's not a disastrous failure. The kinds of failures that you can have in the other model is the server goes down, your entire business stops. So we don't have that problem anymore. We've got the master slave replicating with EBS snapshots. They just work. I mean, you don't really have to think about it. Mark didn't have to go out and learn every little intricacy of how MySQL should work. Fortunately, the MySQL people and RightScale have worked together. They've got that figured out. Why reinvent the wheel? I know you're all developers. You all love to reinvent the wheel, don't you? Everybody's smiling. But don't. It's not good for you. Work on something better. Everything's scripted, so in essence, you don't have manual processes. You don't go out and set this up, set that up, tweak this, tweak that. Everything's scripted. So the idea of going out, let's go hack on the server, don't do that anymore. You've got a better system for that. One of the other side effects, I don't think it's on here, but quite frankly, if you want to test something, if you already have a template, you can clone the thing, try a new version for a while. If you don't like it, you destroy it and start over. When you were running a big single server, that's hard to do. You don't have a second big single server running around. It's hard to put it in and then take it back out. Okay? You can change the architecture as needed. I don't know if that drawing's still accurate. Probably tweaked it.
It's pretty close still.
It's pretty close. So basically the flexibility and of course increased capacity. Now I'm going to try to relay Mark's story, but if I mangle it, please tell me. Mark basically moved to this model about about a year ago, September 1. In October, he was sitting at ZenCon, our conference, obligatory pitch. If you like PHP, you might think about going to ZenCon. And his phone beeped. And he said, Now in the past when Mark's phone beeped, it wasn't necessarily always a good thing. And it was like, the server's crashed or something's going wrong or I've got to deal with it. Pulls out his phone and looks at it. It's a message from RightScale system saying, hey, we scaled up another server because you have increasing load. He looked at it and said, that's nice, put the phone back in his pocket and went back to watching the keynote that he was watching. That kind of sums up in a nutshell, I think, the advantage at the end of the day that you see from something like this, where you can set it up and just have it deal with these scaling issues, and not have to deal with this. So we've got the technology. The technologies exist to let you move these applications without having to reinvent everything. They're there. leverage them. I don't care actually, quite frankly, if you use our technology or not. I don't frankly care if you use RightScale's technology or not. I would prefer that you use both of our technologies for obvious reasons, but there are ways to do this without using Zend's technology, and you could just use RightScale for a lot of it. There are ways to do this without using RightScale's technology and just using Zend's technology. But I think if you don't use some of our technologies, you end up rolling a lot of stuff that you don't really need to roll.